All right, let's talk vSAN. We're going to break down VMware's software-defined storage by tackling some of the biggest, most common questions people have about it. If you've ever thought there has to be a simpler, more scalable way to handle your storage, well, you're in the right place. So let's get right into it. You know the classic setup, right? The old three-tier architecture. You've got your servers, your dedicated storage network, and then these big separate storage arrays. And honestly, it can be a massive headache. It's just so complex to manage, it's super rigid when you need to grow, and don't even get me started on the costs. I'm sure that sounds familiar to a lot of you. And that pain point? That is exactly the problem vSAN was designed to fix. It's a total rethink of how we do storage, especially for virtual environments. The magic is that it integrates storage right into the hypervisor itself. This creates a way simpler and way more efficient architecture. Okay, first things first. What is VMware vSAN? Let's dive into the foundations. The core idea here is actually pretty brilliant in its simplicity. Just think about it. vSAN looks at all the local hard drives and SSDs you already have inside your servers, and it just pools them all together. It creates this one massive shared pool of storage, a single data store that every single one of your VMs can use. Boom. Just like that, you don't need that separate, clunky external storage system anymore.
Okay, but here's where it gets really interesting. It's all about how vSAN handles the data itself. So instead of the old school way of carving up storage into these rigid things called LUNs or volumes, vSAN treats everything as a much more flexible object. And that might sound like a small change, but trust me, that little shift in thinking is what unlocks so much of its power.
And this image? It's the perfect illustration of what I'm talking about. See this? A single VM is actually made up of a bunch of different objects. You've got its virtual disks, its config files, even its swap file. And because each one is a separate object, they can all be managed independently. That's huge. It means you can apply specific storage policies for things like performance or protection to the exact parts of the VM that need them. It's super granular.
Right, so vSAN isn't just one thing. It's evolved over time. Let's break down the two main architectures you'll hear about: the original storage architecture, or OSA, and the new kid on the block, the express storage architecture, or ESA. So, on one hand, you have OSA, the original storage architecture. Think of it as a two-tier system. You've got a really fast cache layer to speed things up, and then a bigger capacity layer for all your data. The great thing about OSA is its flexibility. It can even work with older spinning hard drives. Then you've got ESA, the express storage architecture. This one is built from the ground up for today's crazy fast hardware. It's a single-tier design, which means every NVMe device in the pool contributes to both performance and capacity. No separate tiers needed. So why should you care about ESA? What's the big deal? Well, the benefits are pretty huge. First off, it's got this brand new log-structured file system. And what this does is kind of magical. It gives you the blazing fast performance of RAID 1 mirroring, but with the awesome space efficiency of RAID 5 or 6. You get the best of both worlds. It's built to squeeze every last drop of performance out of modern hardware. Plus, it offers up to 4 times better compression than OSA. Oh, and because there's no separate caching tier, all the devices are working for you all the time. And this evolution leads us perfectly into the next big idea: disaggregated storage. This is really the future of how we think about scalability. The magic word here is decouple. Seriously, that's what it's all about. Disaggregated storage simply means breaking that rigid link between your compute resources, your CPUs and RAM, and your storage capacity. It gives you this incredible freedom to scale one without being forced to scale the other. Think about traditional HCI for a second. In that world, compute and storage are basically married. They live together in the same cluster of servers. So what happens when you need more storage? Well, you have to add a whole new server. And that server brings more compute with it, whether you actually need that extra CPU and RAM or not. But with vSAN disaggregation, that all changes. Now you can create a dedicated vSAN storage cluster. Its only job in life is to provide storage. That's it. And other compute clusters can then just use it. So you can add more hosts to your storage cluster when you need more space, or add more hosts to your compute cluster when you need more processing power. You get to scale exactly what you need, right when you need it. No more waste. And this kind of flexibility unlocks some really powerful use cases. I mean, imagine you've got this monster database. It's eating up storage like crazy, but it barely tickles the CPUs. In the old world, you'd be stuck. But with disaggregation, you just scale up the storage for that one application without wasting a dime on compute cores you don't need. It's a total game changer for efficiency and, not burning through your budget.
All right, let's switch gears. We're going to do a rapid-fire Q&A and tackle some of the top questions we always hear about vSAN. Ready? Let's do this.
Okay, first question, and it's a big one. Do I need all that specialized, expensive stuff like fiber channel switches and host bus adapters that you need for a traditional SAN?
And the answer is a big, fat no. Absolutely not. vSAN is specifically designed to run on the standard network cards that are already in pretty much every server out there. No fiber channel, no special HBAs, none of that. It's a massive win for both simplicity and your wallet. Okay, next up. This is the question everyone has for any storage system. What happens when, something fails? A host goes down, a drive dies, because eventually it will.
So vSAN is built from the ground up for this stuff. It has all these smarts built in. For example, it uses a quorum voting system to protect against something called a split-brain scenario, which is a fancy way of saying it prevents the cluster from getting confused during a network problem and accidentally corrupting your data. So if a drive fails or even an entire server goes offline, vSAN just marks those data components as degraded and immediately starts rebuilding them on the other healthy devices in the cluster. It's all based on the policies you set, and it's all completely automatic.
All right, let's say your business is booming and you're starting to run low on storage space. How do you add more?
Yeah, this quote really nails it. vSAN gives you this just-in-time way of doing things. You've basically got two super simple options. You can either just pop more disks into the servers you already have, or you can add a whole new server to the cluster. Either way, vSAN just automatically sees the new resources and adds them to the pool. It's a really elegant pay-as-you-grow model.
So let's wrap this up. We've seen how vSAN completely simplifies your hardware needs, how it has resilience just baked right in, and how it gives you these incredibly flexible ways to scale, from the original architecture all the way to these new disaggregated models. I think the real takeaway here is that storage isn't this separate, rigid box on a rack anymore. It's just software. So I'll leave you with this question. Is your infrastructure ready for that? Are you ready to stop managing storage and start letting the software do it for you?